Hi guys, I am Mackenzie Cappo, and today we are going to be going over Tropicamide. So Tropicamide is actually something that I chose because it's a molecule that we use in the optometry office I work at to dilate our patients. So we use it quite frequently. It's used in both optometry and ophthalmology offices to dilate the pupil of the eye. It works by blocking the muscle receptors in the eye and preventing it from constricting, so the pupil stays nice and wide and the doctor can take a look into the eye and check the health of the retina, the optic nerve, by looking through the eye. It keeps a nice wider field of vision. Instead of the pupil constricting and the doctor looking through a small segment, they have a wider segment to look through. The molecular formula for it is C17H20N2O2, and the IUPAC name is N-ethyl 3-hydroxy 2-phenyl N-pyridine-4-ol methyl propanamide. If we look at the structure here drawn out, we can label the functional groups. So we have 3 carbons here, which I noted in yellow, noted 1, 2, and 3, and we see on carbon 2, you have the phenyl ring. On carbon 3, we have a hydroxy group. On the nitrogen next to the 1, we have an ethyl group. And then we have a pyridine-4-ol methyl, which I'll elaborate on this page here. So when we're looking at the pyridine, we are going to say that 4 that's in there, it's because we're starting at the nitrogen and we're labeling it, as you can see in blue here. I have 1, 2, 3, and 4. And so at the 4th one is where we have that methyl group coming off, and that's why it's noted as pyridine-4-ol methyl. All right. The chiral center I have highlighted here in yellow. So when we're looking at the molecule, there's only 1 carbon in the molecule that is attached to all 4 different compounds. We see the 3 here that are different, but we also have to pretend like there's a hydrogen drawn in there as the 4th bond. And with 1 stereocenter, tropicamide has 2 enantiomers. Now, if we are to draw out that chiral center and look at the stereochemistry of the molecule, I have 2 different versions here. I have one where the carbon and the OH group are pointing into the page and the hydrogen is pointing forwards. And then on the right-hand side, we have it switched around the opposite way where the COH is pointing forwards and the hydrogen is pointing backwards. If we are to rank them, we see that in all 3, we start off with a carbon, so then we move to the next molecule that's attached to determine which one has priority. And on the first one, we see it's double bonded to the oxygen. And instead of doing like a double bond to the O, we consider this as 2 individual bonds to 2 oxygens. So that first one is the C double bonded to the O, so it's counted as 2 O's. Number 2 is that carbon group attached to the OH, and then we have the carbon ring here on number 3, and 4th is that hydrogen that we drew in. And if we rank them all now, we have the O's. 2 O's are going to take priority, then it's going to be the COH, then it's the ring, and then it's hydrogen. And if we go ahead and draw the arrow, we see that it's going clockwise, which would be R, but because that hydrogen is pointing forwards, we know we need to reverse it. So now it's going to be going counterclockwise, or S. And the other one, where I have it drawn out with the hydrogen going backwards, if we go ahead and we rank it like that, and we know that the hydrogen is facing backwards and that COH group is pointing forwards, we can go ahead and keep it as clockwise, or R. Here are the enantiomers written out. So like we did with our drawings before, that COH is going into the page now, and the hydrogen is coming forwards, so it's going to be ranked and then reversed to make sure that the hydrogen is pointing in the back. So it was R, now it's S. And the other one that we have here with the COH pointing out of the page and the hydrogen pointing into the page is already set up with the hydrogen facing backwards. So we know that we can keep the R when we go ahead and rank the groups as the 1, 2, 3, 4. And I just wanted to include a fun fact here that while I was researching tropicamide, I actually saw that it is a racemic solution. So it means that the solution itself has an equal presence of both the R and the S enantiomers in the medical solution. All right, and thank you guys.